Motion. Scalar quantities. The physical quantities that have only magnitude but no direction are called scalar quantities. Example: mass, distance, time, area, volume. Vector quantities. The physical quantities that have magnitude as well as direction are called vector quantities. Example: displacement, velocity, acceleration, weight. Distance and displacement. Distance. The length of path traveled by a body in a certain interval of time is called distance. Distance is a scalar quantity. Its unit is mile, yard, feet, etc. Displacement. The shortest distance from initial to final position is called displacement. In this figure, we can go from A to B by 3 paths: 1, 2, and 3. In each of them, the distance covered is different. The shortened distance between A and B is path 2, and that is the displacement. Displacement is a vector quantity. Its unit is mile, yard, feet, etc. Both distance and displacement can be denoted by d or s. Speed. The distance covered by a body in unit time interval is called speed. Uniform speed is equal distance covered by a body in equal time intervals. Non-uniform speed is unequal distances covered by a body in same time intervals. The average speed is equal to the total distance traveled by total time taken. It is a scalar quantity. Its unit is miles per hour, yards per minute, or feet per second. It is denoted by U or V. Velocity. The displacement covered by a body in unit time interval is called the rate of change of displacement. Unit velocity is equal displacement covered by a body in equal time intervals. Non-uniform velocity is unequal displacement covered by a body in same time intervals. So the average velocity is equal to total displacement traveled divided by the total time taken. It is a vector quantity. Its unit is miles per hour, yards per minute, or feet per second. It is denoted by U or V. Acceleration. The rate of change of velocity of a moving body. If the velocity is increasing, the acceleration is positive. If the velocity is decreasing, the acceleration is negative and is called deceleration or retardation. The acceleration is equal to the change in velocity by the time taken for the change. It is a vector quantity. Its unit is miles per hour squared, yard per minute squared, or feet per second squared. It is denoted by A or F. Now, let us study the equations of motion. This figure shows the linear motion of a body starting with an initial velocity of u at time 0 in AB. It reaches a final velocity of Fd at time t, and this is denoted by v. The acceleration A or F is the slope of BD. The distance traveled in time t is denoted by S, and that is equal to the area of ABDF. Now the acceleration A or F is equal to the slope of BD, that's equal to DE by BE. That is equal to FD minus AB divided by BE. That's equal to V minus U by T. Cross multiplying, we get AT is equal to V minus U, or V is equal to U plus AT. This is the equation 1. Distance traveled in time ts is equal to the area ABDF. that is equal to the area of the rectangle ABEF plus area of the triangle BDE. That's equal to AB into BE plus half into DE into BE. It's equal to UT plus half into V minus U into T. Now from equation 1 we know that V minus U is equal to 80. So substituting that in the equation we get UT is equal to half AT square. This is the equation 2. The distance traveled in time t is equal to the area ABDF, which is a trapezoid. So that's equal to the area half into AB plus DF into BE. Now substituting these values in the equation we get is equal to half into U plus V into T. That's equal to half into U plus V into V minus U by A. This equation we get from equation 1. So that's equal to half into V square minus U square by A. Or cross multiplying 2AS is equal to V square minus U square. Or V square is equal to U square plus 2AS. This is equation 3. Using this equation, find the acceleration and distance covered in AB, BC and CD. In part AB, initial velocity U is equal to 0 feet per second. Final velocity V is equal to 30 feet per second and time is equal to 4 seconds. Or using equation 1, A is equal to V minus U by T is equal to 30 minus 0 by 4 is equal to 7.5 feet per second. Using equation 2, distance S is equal to UT plus half AT square. Substituting these numbers in the equation we get distance is equal to 60 feet. Part BC. Initial velocity U is equal to 30 feet per second. Final velocity V is equal to 30 feet per second and time is equal to 4 seconds. Using equation 1, A is equal to V minus U by T is equal to substituting these numbers in the equation we get 0. Distance S is equal to UT plus half AT square is equal to 120 feet. Part CD. Putting this now, U is equal to 30 feet per second, V is equal to 0 feet per second and time is equal to 2 seconds. Using equation 1, A is equal to minus 15 feet per second. As this number is minus, we understand this acceleration is negative or it is retardation. Using equation 2, S is equal to UT plus half AT square, that's equal to 30 feet. With this, we come to the end of this lesson. For more information, you can email me at neepa@yahoo.com. Thank you and have a wonderful day.